Okay, I'm going to work out some rational exponent and radical examples that ought to be able to help you with your homework. So let's get started. The first problem, what we're doing is we're multiplying some fourth power radicals together. So the way I'm going to work it is I'm going to break these down and put them under one radical. So that would be 50 times 25. Now I'm going to go ahead and factor those so that I could see what would be a perfect fourth power. So 50 would be the fourth root of 5 times 10, which 10 would be 5 times 5 times 2. That would be the 50. And of course the 25 would be 5 times 5. So you can see that what I really have is I would have 5 to the fourth power times 2 to the fourth root. So the 5 to the fourth power would come out, giving me 5 times the square root of 2. Sorry, the fourth root of 2. The next one will work the same way. So I'm going to combine those under one radical. So I'm going to have 20 times the negative 6. And we're going to take the cube root of that. So let's break that up into the factors. You could do that by a factor tree, but it's just as easy to do it underneath the radical. So a negative 6, that would be a negative 2. Actually, let's do it like this. Let's make it a negative 1, so I can do whatever I want with the negative. So a negative 1 times 2 times 3 times 2 times 2 times 5. So what that would be is that would be a negative, so I could look at that and take the negative out because it's a cube root, so I'm going to take the negative out, and then I have 2 cubed times 3 times 5. The 2 will come out because it's a cube root as 2, so I have a minus 2 times the cube root of 15. Oh, and sorry, I left the 3 off at the front. That should be a 3 when I multiplied it, so that would be a 3. There would be a 3 here. So actually, when the 2 comes out, it's going to multiply by that 3, giving me a negative 6. Okay, let's move down to the next one where we're simplifying these roots. And what you're going to do is you're going to take any perfect cube root out. And remember what we said is that if, like, for example, if I had a, well, let's just do this here. If I would have like an x squared coming out of a square root, since it's coming out with an x to the first power, would have to make sure that that's not negative, so I would have to use absolute value signs there when it comes out. Now, if it would be something such as a square root of x to the fourth power, then what that would come out is an x squared, so the fact that it's squared would take care of the negative, so in that case, that would just simply come out as x squared, and I wouldn't have to use any absolute values. So I only need to use absolute values when I'm taking an even root, and what I'm taking out comes out with an odd exponent. And if I have a cube root, I don't have to worry about it at all. So let's go ahead and work on this one. What we're going to have is we're going to break that 128 up. So 128 is actually, and we're taking a cube root here, and there's a 3 on the outside. So 128 is actually 64 times 2. Then I have an x to the fourth. I have a y squared and a z squared. Okay, so the cube root of 64 is 4, so a 4 is going to come out. And then for my x to the fourth, I will get, actually let me take one more step. And I'm going to break that x to the fourth up into x cubed times x. Now we have y squared, z squared. So we already took the x to the 64 out. It comes out as a 4. This x cubed comes out as x. And notice that my y squared and my z squared can't come out. So what I'm going to have is the 4 will multiply times the 3, giving me a 12. I will have the cube 12x because the x came out. And what I'll have left underneath there would be the 2, this x right here, y squared, z squared. Let's move to the next one. And what I'm doing is I'm taking the fourth root of 243. Oop. Okay, so what I'm going to do is take that 243 and actually I put my cube root there. We're going to break that up into 81 times 3. The x to the fourth, I'm going to leave as x to the fourth. Y to the sixth, I'm going to take and make that y to the fourth times y squared, and leave z to the fourth as z to the fourth. Okay, so for the 81, it's going to come out as the fourth root of 81 is 3. Now this x to the fourth, notice that I have an even root here, and I have an even exponent that when I divide that, that's going to be x to the first, so that's going to have to come out as an absolute value of x. The same thing with this y to the fourth, because when I take the y to the fourth, and since the fourth root is going to come out as y, that's be y would have to have absolute value. And the z to the fourth, it's the same thing. It's going to have to come out as the absolute value of z. So what I'm going to have is I have a minus sign there. That's a minus 3. And I've got the fourth root. And what I'm going to have underneath there, I'll still have a 3. The x is completely gone. The y to the fourth is gone. And I have a y squared. Let me make room to have those absolute values. So I have the minus 3, and I have the absolute value of x, absolute value of y, and the absolute value of z. Okay, the next one. Let's simplify that 50, or break that up into 25 times 2. And I have h squared, it's a square root. And so I think I'm ready to go here. So h squared, j, k to the fourth. Okay, so now the 25 will come out because it's a square root. That's going to come out as 5. This h squared, once again, I have a square root, a power of 2. That's going to be h to the first. That needs to be the absolute value of h. This j cannot come out. It doesn't have a big enough power. This k to the fourth. So that's going to come out as k squared. Now, because it's a square, it'll take care of any negative. It's not going to need to have an absolute value. So what I'm going to have is the negative 2 multiplies by the 5. That's a negative 10. I'll have the square root of 2. And the h squared has come out. Then once again, I forgot to leave room for my absolute value, so put that in there. So I have the absolute value of h, and then I have k squared. And what's left underneath there would be the square root of 2 and j. Okay, let's save those for last. Actually, let's just go ahead and do those. Okay, the first step I'm going to do is I'm going to distribute this exponent in, so it's going to multiply by those exponents. So I'm going to have u 1/2 times 2. So that's going to be u negative 1/2 times 2 would be u to negative 1. The would multiply by the 2, giving me v to the 1/2 times 2 is v to the first. Now down in the denominator, the v here, so take on that square. This u to the minus 2 would take on that denominator, so that power, so that would be u to the minus 4th. And this u to the negative 1 would be u to the negative 2. Now I could have simplified this at the start by trying to simplify inside my parentheses first. For example, I could have taken u to the negative 2 times u to the negative 1. That would have been u to the negative 3. Then I could have simplified that with the u up top. So it really doesn't matter the order that I do it, because we're going to end up having to do that now anyway. So I've got, let's go across. I've got u to the negative 1, v to the first. Then I have v squared, and this u to the negative 4th to the negative 2nd here. Those would add, giving me u to the negative 6. Okay, so now what will happen as far as the v's, the v has a squared and a first power on the top, so the squared is a bigger exponent. So I'm going to take 2 minus 1, which would leave me with a v as a denominator. And up on the, for the u's, I have a negative 1 exponent in the numerator, negative 6 in the denominator. The negative 1 is larger, so it'll be a negative 1 minus a negative 6. That's a negative 1 plus 6, so I ought to have u to the 5th. Okay, for the next one, I'm going to actually simplify before I just, actually, let's do 2 steps at once. So I'm going to go ahead and distribute the negative 3/2 exponent in. That would be a to the negative 3/2. And if I take the b, that would be a negative 1/2 times a negative 3/2. So that would be a positive 3/4. And now in the denominator, I have a to the 1/2 and a to the minus 1. So those two exponents would add. So 1/2 plus a negative 1, that would be to the negative 1/2. And then I have b to the 1/2 and b to the 1/2, and those would add together. So 1/2 plus 1/2 is 1. Okay, so the next step would be to simplify the a's and the b's. So what I have is I would have so let's go ahead and simplify the a's. So the largest exponent is a to the negative 1/2. So what this is going to be is, for the a's, I'm going to have a to the negative 1/2. And if I subtract a negative 3/2, that would be plus 3/2. And that would all be in the denominator. And for the b's, the b is the largest exponent. That would have an exponent of 1. So 1 minus 3/4 would be b to the 1/4 in the denominator. So what I would have is I'm going to have 1 all over negative 1/2 plus 3/2. That's 1. So I've got a b to the 1/4. Now technically, this shouldn't look like this, because what I have is I have a 4th root in the denominator. So although this is the right answer, I'm going to rationalize the denominator to try to get that b to be b with a whole number power. So what I'm going to do next is, if I take 1 all over a b to the 1/4, and if I need to multiply by something that's going to make this b have an exponent that is like 1 or 2 or something like that. So if I take the top and the bottom times b to the 3/4 power, b to the 3/4, what I'm going to get now is I'll have b to the 3/4, and in my denominator, of course, I still have the a, but the 1/4 plus the 3/4 is going to give me b. And that's really the correct way to write this. So now that you can see I don't have any rational exponents in the denominator, which means I don't have any radicals, which is really how it should be written. Okay, moving to the next problem, what I need to do is I need to get rid of the cube root of 4 in the denominator because we're not going to have any radicals. My next perfect cube root is going to be 8. So if I can multiply this times the cube root of 2, all over the cube root of 2, what I'm going to get is I get 3 times the cube root of 10. But then I get, in the denominator, I get the cube root of 8. Well, the cube root of 8 is really 2, so we could rewrite that as 3 times the cube root of 10 all over 2. And notice that I have no radical in the denominator. Moving to the next one, I have the fourth root of 27. So my next perfect fourth root would be if I could make that the fourth root of 81, which would be 3. So to get 27 to become 81, what I need to do is I would need to multiply both the top and the bottom by the fourth root of 3. So now what that's going to be is a minus the fourth root of 3 all over 4. The 27 times the fourth, times 3, those are both going to combine to earn a fourth root, would be the fourth root of 81. Well, that's simply 3. So I've got the fourth root of 3 all over 4, and this is the fourth root of 81 is 3, which would multiply by the 4, giving me 12. Okay, the next problem is what we have is we have a square root in the denominator again, and what we need to do is we're going to multiply by the conjugate. So we'll take that 4, and we're going to take the numerator and denominator, and we're going to multiply it by the conjugate of the denominator. So that would be multiplying by 3 plus the square root of 5 all over 3 plus the square root of 5. Okay, so what I'll have in the numerator, I'm going to have 4 times 3, I have 12. 4 times the square root of 5 is plus 4 times the square root of 5. And my denominator, it'll be like the FOIL method. 3 times 3 is 9. 3 times the square root of 5 is plus 3 times the square root of 5. Negative square root of 5 times 3 is minus 3 times the square root of 5. And then lastly, I have a minus the square root of 5 times the square root of 5 would be minus 5. Okay, so I've got 12 plus 4 times the square root of 5 all over 9. Now my square roots of 5 in the denominator go away, so I have 9 minus 5. So I'm going to have 4. Okay, so what we can do now is we need to simplify that. So I'm going to factor a 4 out of the numerator. So that would be 4 times 3 plus the square root of 5 all over my denominator of 4. Now then, since I've got multiplication, I can cancel those 4s, and I have 3 plus the square root of 5. Okay, let's go to the next one. So what I'm going to do is I'm going to multiply both the top and the bottom by the conjugate of the denominator. So that would be the square root of 2 plus 5 over the square root of 2 plus 5. And that's going to give me, I still have my minus, so I've got 4 times the square root of 2 plus 20. And in the denominator now, I'm going to have the square root of 2 times the square root of 2. That'll be 2. 2 plus 5 times the square root of 2. Now my minus 5, so that'd be a minus 5 times the square root of 2. And lastly, a minus 5 times 5 would be minus 25. Okay, so simplifying again, I've got a minus 4 times the square root of 2 plus 20. And in the bottom, I'm going to have 2 minus 25. That would be all over negative 23. So since what I have is this whole thing is really a minus, notice that the minus is out in front there, and I can take this minus off the 23 and move it out also, so the minus out here and the minus on the 23 are going to make that a positive. So I'm going to have 4 times the square root of 2 plus 20 all over 23. Okay, let's see, and the last problem is we need to combine those radicals. Now, I can't combine those radicals unless they have the exact same power, which they do, and the same number underneath the radical. So let's go ahead and see if we can simplify those to get the same number underneath the radical. And sure enough, I can take this and make the cube root of 48. That's going to be 8 times 6. Well, the cube root of 8 is 2, so that 2 is going to come out. The 8 will come out as a 2, so I've got 2 times the cube root of 6. That 2 would multiply by the 2 that's here, giving me 4 times the cube root of 6. So now I have 2 plus 4. I have 6 times the cube root of 6. Okay, over here, I have to do something similar. So what I'm going to do is I've got 3 times the square root of 20. Let's make that 4 times 5. And over here, I've got the square root of 45, and let's make that 9 times 5. So this will come out as a 2. This will come out as a 3. And what I'll end up with is 3 times 2 is 6, times the square root of 5, and minus this 3 hits come out, 3 times the square root of 5. So look, I've changed it so that I have the same radical, same powers as the square root. So that's going to be 3 times the square root of 5.